Michigan Tech's SICK LiDAR Challenge team presents ServoTron, the server of the future.
In this contest, we were tasked with using a LiDAR machine for our project. A LiDAR shoots out rays of light and measures the time it takes to return to the LiDAR. Using this, it can calculate the distance from itself to the nearest object it detects. For our project, we decided to combine a camera with our LiDAR to be able to dynamically detect objects and have our robot avoid collisions with these objects. As shown in this demo, our robot approaches a wall of boxes and is able to see that they are there and turn to avoid collision with them. While our robot traverses the room, it is compiling scans of the environment that it sees. Once it completes its path, it will take these scans and create a map of the room. This is the map that is created at the end of the robot's journey. It shows the room that it mapped along with the path that it took while traveling. Because the LiDAR is on a perch, it doesn't always detect objects below it. To combat this, we used programmable bumpers so that if the robot hit an object, it could still turn, avoid it, and continue traveling.
One of the most important functions is the implementation of the simultaneous localization and mapping, or SLAM algorithm. The SLAM algorithm allows for the compilation of individual LiDAR scans to create localized maps, which allow distance tracking, room mapping, and the mapping of a traveled route. The combination of all these capabilities allows for our product to fit two separate markets. The first being an improved Roomba. By tracking location, it is able to track where it has already currently cleaned instead of traveling at random. This helps to avoid excessive power usage and to create a more efficient cleaning robot.
Along with the SLAM algorithm, our robot is able to dynamically view its surroundings. This makes it so our robot does not have to run into an obstacle to know that it has to turn. Moving objects such as people and pets also would not affect the robot as it is dynamically viewing the area. Shown here is a current Roomba that is running into the walls and cleaning the same door entry multiple times. With our improvements, our robot will only travel through this area once. This could be marketed to the Roomba company as an upgrade to its current model. The new model would be more efficient while being less intrusive. The second market would be a restaurant server. As shown in this video, restaurants can get extremely busy, and when they are, this increases stress for workers and points of contact between people. This is especially important in our era of COVID, where we want to keep people as safe as possible while still giving them services. ServoTron would reduce stress for workers by taking an aspect of their job, and it would reduce points of contact between servers and customers, further limiting the spread of contagions. We designed a simple concept in NX 12 of what could be put on a robot to help deliver food. This would reduce stress of workers by helping them run food, and it would be one less point of contact. Shown here is a poll that we sent out to friends who had worked in the food service business. From the chart, the majority of people said they were at a stress level of 7 to 9, which is a high level of stress while working. In a typical restaurant, ServoTron would relieve stress by delivering food and retrieving dirty dishes, which would alleviate workers of two tasks.
To show our implementation of ServoTron, we created a demo where a team member placed their wallet on the robot and had it navigate to a set destination. As it travels, it will continue to avoid objects as shown in the video and still be able to travel to its end goal, therefore avoiding customers and any objects that it might affect in its path. This will continue to travel until it reaches the predetermined location. It is then able to stop, and the customer would be able to grab what they ordered, therefore limiting points of contact.
Using these tools, ServoTron is on the up and coming, and LiDAR is the technology of the future.